Hey everyone, this is our presentation for the CS410 camera stream project number 9. First, let me introduce you to our team. Francis as a Scrum leader and the backend and the front-end developer, and Priyansh as a UI developer, and me, Robert Kevin, as a backend developer. Can you
So
change?
here
Can you
is the team. Yeah.
Yeah. So this is our team. Okay. So this is our workflow this is our GitHub board, and these are the um like the things we have done so far in the project, and this will show you the progress that how we started the project with and how we ended up. And can you go to the next screen, Priyansh? Okay. So we have used a number of tools for this projects. Now let me walk you through each of them. So the first one will be Atsign. We used Atsign to ensure the privacy of message sent through our UMB messenger. And the Java is the main programming language that we used for the overall application. And the Spring Boot. The Spring Boot was used as a backend host to store the user's details. And the webcam, we used webcam as a tool, for the video streaming thing. And the AWS is used to host the backend part in the as a host. Can you go to the next one? Okay. Yeah. So here's the funny scenarios. Just consider a scenario where the UMB students faces challenges in locating their peers on popular messaging apps like Discord and WhatsApp, and even emailing them has proved to be slow and tedious. So that's why we came up with the solution. We devised a solution in the form of UMB Messenger, which utilized the Atsign technology to offer a secure and user-friendly interface. By searching their peers' email address, users can easily locate and connect with each other. Moreover, we added camera stream features to our messengers, enabling users to stream video in real time. And the planning phase. So about the stream camera footage, our main objective was to stream a camera footage between users. So when we came up with when we were like thinking about this phase, Jeremy helped us in by showing us a demo, like how two programs can communicate using Atsign protocols. So that's how we learned how to use the Atsign. And about the camera footage thing, it was a little bit it was not that easy for us to really like stream a footage from one user to other users. We had to go through a lot of researchers to do that. And yeah, so this is our early UML diagram. So the first one was we had two applications running, one as the host, Java host, and another one was the Java client. So first, our objective was to try connecting them with Atsign protocols, and that's how we started the project with. And later we improved a lot and came up with the. Can you move to the other slide, Priyansh? Yeah. So this is our current workflow. So the current workflow works as um, the user can be like any number of users. So every users can sign up um, using the backend server, which is running on AWS. It's a Spring Boot microservice. So the client signups, and the after signing up, the it stores all the information of the client in the backend, and which is then be used by other users when they log in, which shows the list of friends that they have in the backend database. And the Atsign protocol, about the Atsign protocol, end to end, it's encrypted. We have never stored any of the users' I mean, like the messages or the stream, we have never stored it anywhere. It's end-to-end encrypted. The chat system works with two users. Previously, we were like executing it with three users, where one client communicates with the host, and the host will communicate with the other users. But then everyone suggested that it's not a secured system, as it is connecting with another host. So we came up with another idea of like chatting within the users, like one with one user and the other. And even the camera feed doesn't uses another host. It just uses two users encrypted at-signed keys to communicate with each other. Can you go to another slide? Yeah. So this is our about the expanding the project. Our future plan involves building upon the existing camera stream features and privacy advantages offered by Atsign to create a comprehensive messaging platform. This would provide a ideal solution for the UAB students to communicate with each other in fast and convenient way. And Priyansh, can you? Yeah. From now, that's it. Thank you so much. From now on, Francis will continue the presentation.
Hello, I'm Francis, the Scrum leader, as presented initially. So I'll be picking up from here. So, why a messenger? We decided to go for messenger because we wanted to do more with just streaming a camera from A to B. So we thought that hey, this would be a great opportunity to utilize our camera feature. Privacy. Atsign is really great about privacy, so we wanted to do more with what we had. And it's also a great idea. And we were very ambitious and we're very proud of our end result. And as I said, why Atsign, right? Privacy. It's the most important thing ever. Next slide. So why Spring Boot for hosts in AWS? It is primarily for fun. This is something I had experience with, and I wanted to educate my peers on it because it's something I had experience with. So I thought this would be a great way to teach them as well how to create endpoints, how to deploy the stuff to AWS, working with databases, and in short, to, in essence, emulate a real life working experience. Next slide. So this is a very general, a showcase of what our microservice does. It's very bare bones. Users sign up, they put in their email, the school email. There's a get end request where it gets users who are online. There's the put endpoint request, which updates whether a user goes online or offline, and delete in the event they want to delete their account for whatever reason. Next slide. Cool. So here are some example of the endpoints that's on our microservice. So on the top left, that is our get, where you just fetch the online users. There's the top right, which users can sign up. You just pass in a JSON of the body. There is the update operation, where users will update whether they're online or offline, and as well as the delete at the very bottom right. And at the very bottom left is the structure of our backend. Next one. So could this be a security issue? No. So all our communications are done on our clients, which are heavily dependent on @sign services. So our backend only saves users and encrypted user names and emails. This is an example. So on the left side is on a client where the client just signs up and then it encrypts their encoded username and sends in their school email because our messenger is partnered with the school. And on the very left, it seems like it's a little bit trimmed, but you can get an example of what it looks like. The username is very unreadable. It's just a bunch of words. And the email is just a school email. Next one. Here's an example of our client with our Atsign connection manager. And this is how we are, in essence, establishing every connection using Atsign. Not users, I apologize. So whenever we establish a connection, we call @sign connection manager. If it's a receive, we call in the receive function. If it's a send, it's a send. And yeah, it's very straightforward, very easy. Here's a great example of receiving with @sign. This is the chat area class where once users are communicating through our little chat system, we have a thread that's running, and the thread is requesting data from @sign, and then it just populates it on the chat area. Next one. Oh, there's a picture up ahead as well. Sending with @sign. This is how we send with @sign. We encode the video, and then we put it within a JSON format, and then we send that through @sign. And yeah, I believe that is all. So I think I'll now be passing the torch to Priyansh.
Hey everyone, I'm Priyansh, and I'll be taking it forward now. I was working on for the most part, I was working for the UI. So this is our workflow where it started. So our initial idea was to create a sign up page and a login page. The sign up uses the data provided by the user to store the user for taking it to the UI, and that's how it progressed as we worked on. So these are some primary stages where we were headed. Okay, so our initial idea was to take the user and uh, take their @sign and the display name, which would be their when we play a game or something, it's gonna be their name, which whatever they wanted, and then using that name, they can connect with their friends here on the UI. And initially, all the UI components were disabled, as without selecting a friend, it was of no use to be access to this component. So as soon as the friend was clicked, all the oh sorry. As soon as a friend was clicked, all the components were enabled and the user was allowed to chat, communicate, or like stream the video with his friend. So here's our chat component. As Kevin mentioned earlier, first we were using a host, and now we're not, because we had some security issues brought upon, and we considered that, and we took another approach in which we found out a way that there's a way that we can send a data from one @sign to itself. So the @sign sends the data to itself and also to a friend. That's how we are ensuring the security that the data is not transferred anywhere. This is our webcam component. This is like our initial test where we tested the webcam. UI, yeah. So UI is always challenging, and yeah, we have to be flexible while designing the UI, because we have to be flexible whatever backend changes are made, and our UI should function good along with the backend. Good. So this is where we wanted to go first. This is our initial design of how the UI should look, and then we moved forward here to here. So this was what we showed in our dry run, and I'm excited to show where we are now from here. So now I'll demo our work. You guys ready?
Yeah, Priyansh, we are ready.
Okay, cool. So this is UMB Messenger. Now we will use the @sign, my UMB email. Now I sign up. Cool. So now I'm gonna chat with Francis and Kevin. Sorry. Hey guys. Hey, look, it's working. So let's show them our cameras now. Hello, everyone. It's a little glitchy, but it's better than where we were first. Say hi, Kevin. Yeah. And this ends the chat. And everything is disabled again. We can simply select them again and start everything. Now, whenever there's a user present here, it's not going to take us to the sign up. It's just directly going to take us to the login page. I guess that's it.
All right, so me and Nick did project 8, which is the heart rate monitor. So to introduce ourselves, I'm Zach. I kind of worked a little bit on both the front end and back ends, but primarily back ends. So for the back end, my work included setting up the pulse rate sensor and then calculating the heart rate from that, and then sending the data to our app. And then for front end, I did some UI design and worked with Flutter with Nick.
Hi everyone, my name is Nick. So for this project, I mainly worked on the front end, mainly the UI design, and I work with Zach together on integrating backend and front end.
All right, so the problem. So the problem we are trying to face is a quiet but serious issue, and that is irregular heart rate. So I say it's a quiet issue because a lot of people don't know, or if they don't monitor it, they wouldn't know that their heart rate is irregular. And this is pretty serious because irregular heart rate, whether it's too low or too high, can, indicate a lot of various different health problems and cause many like unwanted symptoms and stuff like that. I pulled this stat from USC that says more than half of all Americans aged 20 and up suffer from hypertension, which is high blood pressure. But as you know, high blood pressure and high heart rate go hand in hand. So this is a very common issue and something that really does need monitoring. And hypotension, which is low blood pressure, is also an issue. So I basically am saying that the issue lies in unawareness, because this is something, if you're not monitoring your heart rate, you probably wouldn't know unless you go to a doctor and they do a checkup on you. So it's something that's important to watch on your own. So our app solution. So we're trying to monitor the user's heart rate on demand via the @sign. So with heart rate, it varies on age. Like a younger person is going to have a higher heart rate than an older person. So we wanted to make an app that you could input your age and it would read your heart rate based off the sensor and stuff like that and tell you, okay, this is your heart rate. It's either too high or too low or in the good range for your age. And then, so if it is too low or too high, we wanted our app to basically give the user potential remedies, because usually this is stuff that you can solve at home, but if it prolongs over time, then it does get serious and you need to go to a doctor. But we wanted to give some of these potential remedies to help this. And here I just included a picture of our ESP32 setup. So this is our pulse rate sensor. Basically, the user would put their finger on this little area where the red arrow is pointing right there. And this, where the blue arrow is pointing, the light would shoot down, and basically it reads light levels, and I can then calculate a beat per from that, and then calculate beats per minute, which is the heart rate. So our use case. So we have this scenario that someone named Joe, he's 22 years old and he's been under a lot of stress lately. Knowing this, he's worried about his heart health and he wants to use our app. And before I run the demo, I'm just going to explain real quick how it works. So as I mentioned, we start with the ESP32 and the sensor. And the ESP, like once that reads that value of the heart rate, it's going to use @sign to then send it to our app. So I'm just going to play this and you should be able to hear me again in a second. Okay, so now for the demo. So the first step is obviously you need to take the heart rate with the ESP32. Just to save a little time, I've already done that. And this is the output. So basically I have my C++ code right here that reads what the sensor is inputting, which is light levels, and it does some calculations based off the readings and determines what's a beat. And it does that over the course of 15 seconds and then multiplies what it got by 4 because obviously 15 seconds times 4, that's 60 seconds. So you can say that's beats per minute. So each time there's a beat, it outputs beat, and then it has a count of the final beat and then multiplies that by 4, and that's the heart rate, which is on the higher ends, which is good because just did some jumping jacks to make sure that I'm a stressed out 22-year-old or whatever the demo case was. So once we did that with the ESP32, it will then use the @sign to then send it to our app, which is over here. So this is just the basic, like we did in the tutorial about receiving data from the ESP32. And what this does is it reads what data is being sent from the @sign, which is in this case, our heart rate. And it is then going to output a file with the heart rate. And it also, just for test purposes, I'll show you, I can run this and it will show you what the heart rate is, sorry. So if I run that, it's going to fetch what's been called through the @signs. And it's going to tell us our heart rate's 120, perfect. And then it's going to output, I said, the heart rate.txt file and 120, so that's good. All right, so now the final thing is the app. So we did this with Flutter. A main.dart file is then going to read what the heart rate is and then display that. But first we need to enter our age because heart rate can the normal heart rate can vary by age. So I believe in my case, I said Joe is 22 years old. So I'm going to say 22. And here it is. It says your heart rate is 120 beats per minute. And it's basically telling you that your heart rate is too high for your age and gives you some tips, as I mentioned, to lower it. So that's good. I do want to show you. So like I mentioned, it could be based off age. So like a 9-year-old's heart rate isn't gonna, or expected heart rate isn't gonna be the same as a 22-year-old's, because as you get older, your typical heart rate is gonna be lower. Like older people have a lower heart rate than younger people, obviously. So say your user is 9 years old, it's then going to tell you that you have a healthy heart rate, which is good because, like, as I mentioned, 120 beats per minute, even though it seems high, is typically normal for that age range, which is good. So that's our demo. And yeah, that's how a user would typically use our app. Yeah, and now I do have some slides just to show that stuff more in depth. So this is our C++ code. This is all about the ESP32. I mentioned in the demo how we have, I have this while loop that kind of calculates the light levels. So basically, if the ESP32 is constantly reading light levels, and when you put your finger there, if the old reading is greater than the new reading, that means there was a beat. So the ESP32 can then calculate and say like, okay, there was a beat, I'm going to increase the count and stuff like that. And I also have it so it blinks as your heart beats. And then I just did that for 15 seconds. And once that was up, I multiplied that. So yeah, so my C++ code then uses an @sign for its ESP32, and from that @sign, it sends to another @sign that I have representing our app. And that's this. So the ESP32's @sign is the 60 melted, and our Java is the bittersweet. So this outputs to a file. Ideally, I would have liked to just directly input this @sign stuff into the Flutter app, but I was just having issues with it with Flutter and stuff like that, because as Jeremy mentioned, Flutter is very difficult, and this is my first time using it. So I just output it to a file, and then the Flutter app reads that. And then this is just another scenario. So this is a new reading. This time it was 96 beats per minute, which was much better. And then the app then recognizes, okay, hey, your heart rate's 96 beats per minute. I inputted my age, which was 22, and 96 is a good heart rate for the age 22. And yeah, so problems encountered and lessons learned. There were many different problems, but we picked some to talk about here. So my big issue was issues with the sensor. So the pulse rate sensor I got was tricky because everything I found online was, it looked like a kind of like, you know, like the heart rate like pads or whatever that you put up against, and they can like detect like heart rate. This was different because this was reading light levels, and I'm like, okay, like how the hell do I get a beat like reading from that? But after some time, like I was able to come up with that formula and looking online and stuff like that. And also another issue was wiring. A lot of people, like a lot of like things online didn't use ESP32s with this sensor, so just wiring it up and stuff like that was difficult. But like I said, I eventually got a reading that made sense, and I checked it alongside like with another heart rate monitor, and it's now working. So lessons learned from that, basically, I've learned how to do like, you know, get light readings from the beats per minute and then send that over to an app. So that was useful. And then Nick.
Yeah, so the main problems I had with UI designing was that putting multiple elements in one page can sometimes be tricky because for different screens, sometimes the elements, they overlap with each other. So I eventually had to go for a simpler design, like you saw in the demo, which had 3 pages. And another problem was getting the data, like Zach said earlier, from the Java app to Flutter. And he eventually figured out a way to put it in a text file, and I was able to get it into the main file in Flutter and read it from there.
Yeah, and then just another problem was obviously like anytime it's a group project, it's difficult at first to like learn how to work together. The biggest problem was finding time to meet and stuff like that. And I felt at first that we were both kind of making like 2 individual projects, because Nick was working on the UI mostly at first, and I was working on the sensor. And obviously, if you're working on a group project, you need to learn how to combine those 2 things together. So towards the end, we really did that, and I'm proud with the results. And lessons learned from that is time management and communication. We learned how to talk through what each of us is working, and how we want to implement that into each other's work. And then, I mean, if we were given more time, I would have loved to add more to the app. And like I mentioned, like I would like getting the Atsign directly fed into the app, and then also just like a cleaner page of like remedies and stuff like that, and a more interactive page. But as I said, I'm proud with how it came out, because it does serve its purpose that we originally wanted to accomplish. And that's all we got.
Okay, so my project was making a humidity and temperature monitor. So broadly, what I was doing was taking this device here and making an app that correlated with time. Can you see the app up here? Or do you just see the PowerPoint?
Just the PowerPoint.
How do I share the screen to be, I can just do the screen. There we go. Sorry about that. Do you guys see the app now?
Yep.
Okay, perfect. So I just had this running in the background. So this is the app. So basically what I do is you hit the new data point. We have the ESP32, and then you get an updated temperature and humidity reading. So I just thought it was easier just to introduce broadly what the app did before I started the presentation. So these were the tools that I used for the presentation. I used VS Code along with the ESP32 that used the @sign, which then went to a Java program where I used IntelliJ and Java FX using Scene Builder to design the UI. So those are the overall tools that I used for the project. The reason that I made a temperature and humidity monitor is because I've had issues with temperature and humidity in the past in apartments that I've lived in, where like the heat hasn't really worked all that well, and then water leaks and things like that. So monitoring the temperature and humidity has come in handy at various points. So I just put some reasons here beyond just pure comfort, why it's a good idea to monitor humidity and temperature. Like, you know, because high humidity can be damaging to artwork. Some medication needs to be stored at certain humidity levels, instruments, shelving, carpets, etc. High humidity in particular can be pretty bad. But most monitors, like the one that I have here, only really monitor the current temperature and humidity along with ranges, but don't really do a good job in including time in that. So that was the goal of my app. So I have this device, I have an @sign, and I have a clock. And my goal for the app was to combine all of those into one place along with some statistics that varied over time. So what I have here are 2 scatter plots, and I have it set from 8 in the morning until 11 at night. And what these dots are is a continuous range of the temperature and humidity in my apartment over the span of the last 2 weeks. So I have a good idea on what, for instance, like if you see the humidity here, it's higher in the morning and lower in the afternoon. And the temperature, I think once the summer, once it gets later in the year, the temperature should be higher in the evening. So I'm able to identify trends that can help with things like running the air conditioner and dehumidifiers if needed. So the process for the app broadly was, I have the ESP32 sensor here, and it is connected to VS Code that sends the data to the Java app. And then the graph collects the data over time, and then the trends are seen on the left here. So this is just another, I just put this along with the code that I have. So here's the sensor. And then I put an @sign next to the pieces of code that use the @sign. So this is the VS code. This is how I used the @keys in the code. And then this is the, this is the transfer class that I used in Java and how I got the @sign values into the Java program. And this is the code that I used to retrieve the data from that class when new data point was hit. So I'm going to run my demo now. So what I have here, you can see the @sign is running currently. It's sending over data. Here's where I've been keeping a running total of the data points that I've collected. This is the main controller class that runs the UI. This is all the code that takes the array values. It takes the values, I'm sending them over from the transfer class and putting them in a 2D array. So when I click the button, it's going to run get current and then update the values. And then when I hit the values, you should see, this is the humidity. You should see a new value there. So it'll take a minute to upload. And then there you go. So that's the demo. And then that should also be the same for the temperature and then the averages and things like that as well. So the things that I learned is that projects like this, you can always start early. You know, it took us a while to get our devices, but in retrospect, there were a lot of things that could have been done before the devices were in. And, you know, even if like you don't have a perfect plan, it's always better just to start something. And like the worst that happens is you do work and then it gets discarded. But that's still not so bad because then there's always something that you can always go back to if things go wrong. The second lesson that I learned is knowing when to pivot. You know, like I started using Flutter, and for the skill level and the amount of time that I had, I couldn't quite figure it out. And when that became apparent to me, I switched to Java FX. I think really I should have made that decision a few days before I did. And if I did, I probably would have had something that was just slightly more involved. But on the flip side, sometimes like working through something that's a struggle is worth it. And there were definitely points where I thought about changing, but that would have been, you know, just one too many change. Also, I'd like to thank everybody who helped me with this project. And I think it's also important to talk to people who, especially in a project like this, where we're all doing effectively the same thing, you know, to communicate with other people and to see if they've run into issues and what kind of, you know, I definitely talking to people, particularly people who used Flutter, or even like talking to some people who did things with the @sign. You know, that was really valuable information to me that probably saved me a lot of time. So yeah, all of you guys, you know, I must have talked to maybe about 10 of you. You guys were all really, really helpful in this, and I want to thank you for that. And that is my presentation.